Hello, I'm Mr. Parker and this is question 3 on the OCR Mechanics 1 paper from June 2013. For more questions on this exam paper, click the link here or check in the video description. Question 3. Two forces of magnitudes 8 newtons and 12 newtons act at a point O. In part 1 it says, given that the two forces are perpendicular to each other, find A, the angle between the resultant and the 12 newton force. So we have a 12 newton force and an 8 newton force, and these two forces are perpendicular to each other. In order to find the resultant, what I'm going to do is take this 8 newton force and I'm going to put it at the end of the 12 newton force, and my resultant will be the force that goes from the beginning of this vector to the end of this vector. So the resultant is like the hypotenuse in a right angled triangle here, and I'm going to call that R. I'm interested in finding the angle between the resultant and the 12 newton force. Well, here's the 12 newton force and here's the resultant, so I'm trying to find this angle in here, which I'll call theta. So I can find this angle using a bit of basic trigonometry. I'm going to say that tan theta is opposite over adjacent. The opposite is the 8 newton force, the adjacent is the 12 newton force, and so to find theta I just need to do inverse tan of 8 over 12. And that gives me 33.7 to 3 significant figures. In part B, I need to find the magnitude of the resultant. All that is the length of this vector. And to find that, I'm just going to use Pythagoras. So I'll say that r squared equals 12 squared plus 8 squared. That's 144 plus 64, which is 208. So to find r, all I need to do is square root 208. And that gives me 14.4 to 3 significant figures. In part 2 it says it is given instead that the resultant of the two forces has magnitude r newtons and acts in a direction perpendicular to the 8 newton force. In part A, we need to calculate the angle between the resultant and the 12 newton force. So we're trying to figure out this angle here, theta. First of all, we need to decide which direction to resolve in. Now, if we went in the x direction here, we'd have r, which is an unknown, and we'd also have this theta involved because we do 12 cos theta to find the component of this 12 newton force. So there'd be two unknowns and we wouldn't be able to solve that. However, if we look in the vertical direction, that eliminates r because that will be perpendicular. So the only two forces we've got are the 8 newton force going up and a component of this 12 newton force going down here. Let's take upwards to be positive. So we've got an 8 newton force going upwards. If we were working horizontally, the component of the 12 newton force will be 12 cos theta because that's the angle in between the force and the direction. So if we want to go vertically in this case, we're going to get 12 sine theta. Because the component of this 12 newton force will act downwards, we want that to have the opposite sign. So we get 8 take away 12 sine theta. And because there's no vertical component in this resultant, that means this force must cancel out with this force, so that equals 0. Rearranging it gives us 8 equals 12 sine theta, and 8 over 12 is sine theta. So to find theta, all we have to do is inverse sine of 8 over 12, and that gives us 41.8 degrees. Now that we know this angle theta, we can find this resultant force, because that means when we resolve horizontally we now only have one unknown. And the component of this 12 newton force going horizontally is 12 cos theta. But we've already figured out theta, it's this value here, but we've got it more accurately stored in our calculator. And the component of this 12 newton force must have the same value as the resultant force here because the 8 newton force is perpendicular and doesn't affect it. So we can say that that equals r. Putting that into our calculator gives us 8.94 to 3 significant figures.